Hi, as you might have known, this is the session about working with legacy code in C++, which some of you probably do, judging from the size of the room and the amount of people. Let's start, quick introduction. My name is Dror Helper. I'm a consultant, freelance consultant, and a software architect. I work mainly in the three object-oriented, well-known object-oriented languages, C++, Java, C#. That's what I mostly do. Write a lot of code, been doing that for more than a decade. Judging from the white hairs in the room, probably most of you are as well. And I've been doing that for some time. Been very frustrated in the beginning because I tended to break a lot of the code as I was writing it. And somewhere along around 2005, I worked with a company which were a very agile shop with TDD and unit testing, and I've become very in love with the topic in a way. And ever since, I've been advocating how to write better code, helping developers make try to write better code so they can maintain it. Been talking at conferences as well. And I like to think of myself as a test-driven developer as well. I'm also a Pluralsight author. I have a couple of courses on Pluralsight, two of which about C++ unit testing. C++ fundamentals unit testing with Catch, a framework I like and love, and I'll talk about that tomorrow. And another one about mocking with Google Mock. And that one has a module about legacy code as well. You might want to check it out, because I won't be able to talk about everything I like to in 45 minutes. And if you like to hear more, then that's a place to be. Also, I have a blog at helpercode.com and Twitter handle, thehelper, easy to remember. Yes, this is my name. And all of you probably wrote helper functions in the past, and so it's easy to remember. And we need to talk about legacy code, right? Anyone knows the exact definition of legacy code?
The stuff you just wrote.
The stuff you just wrote is as accurate as it can be, basically.
It doesn't have to run. No.
Yeah.
Well, certainly not mine, anyway.
Yeah, I remember back in university, we had a very hard, difficult exercise. It took us about a week to write. And I was very frustrated to ask someone who was with me in that class whether or not he managed to finish the exercise in time. He says, yeah, it compiled. So yeah, it doesn't have to run. Unfortunately, there's no clear definition of legacy code, never was. There is a definition in a book called Working Effectively with Legacy Code. Anyone ever read that book? Okay, it's a very good book. It's about 50 or 20 years old book. And still, everything there is still current and still good, especially if you're in C++, because that's what he used for most of the book. I actually created a unit testing framework for that book, written by Michael Feathers, by the way. And his definition is code without unit tests. But even he knows that it's not an exact definition. But you know what? Anyone here in the room can probably recognize legacy code, right? When you see it, you know it. It's a feeling more than actual facts. It's a feeling I get in the pit of my stomach when I look at that code and I think, oh hell, now I need to do something with it. And that code was probably written in the past, could be a week ago, usually more than a few years, by someone who had no clue what he's doing, using obsolete method and obsolete tools. We want to work with modern C++. Most of the time, it's not exactly modern C++. Sometimes it's not even C++ at all. And we need to somehow traverse that code. And we know it when we see it, right? And there is no clear definition, but there are some properties of legacy code which I found to recur whenever I need to work with that code. The first of which is that it is no longer designed or engineered, just continuously patched and hacked. You know what I mean. In the beginning of every project, the best time to be in a project, in the beginning of a project, there's architects and design meetings, and we come up with this beautiful, elegant design, which failed to meet all the needs, but at least some of them. And we start writing the code. We even release a first or second version, and then we go away. Someone else is left with that code to maintain it. And that guy doesn't know this beautiful, elegant design, never heard about it, might not read the documents, if there are any design documents. And if there are design documents and architectural diagrams, they are probably wrong because they became obsolete. The code has changed, and the design in the Word document, PowerPoint, slides, whatever, was left behind. And so the maintainer is left with patching up things and making the situation even worse. And you tend to find very big classes with long methods. I've seen methods 10,000 lines long. And the only way to fix a bug in a 10,000 long method is to put a breakpoint in the beginning of that method, run with your debugger, if you have a debugger, be in a C++ room, but let's say you have it. And you get a point that looks okay-ish to you. You write your code. Maybe you run it a couple of times if you can, because not all application can be run on my machine. And commit and run away. And the reason we're doing that is not because we're bad developers or bad persons. It's because legacy code is easily broken. You can easily, without intending to, break features that have absolutely nothing to do with the fix or the new feature you are trying to implement. A client of mine had a problem in the middle of the night. One of the customers, big customer, called because some core functionality stopped working. And it was a very stressful period, which took a few days, in which we read a bunch of logs and debugged the system until we found the problem. And once we found the problem, we wanted to know how the hell it happened. So we opened the history in the source control and found out something very interesting. First, the fix had nothing to do with the problem. Basically, someone changed a feature, and somehow that caused the issue in another part of the system. But the more disconcerting fact was that that specific bug was introduced a month before the client noticed. And that's what we are afraid of. Because if I'll find the bug immediately, no problem at all, I'll fix that. I remember exactly what I did. But after a month, trying to understand all the changes, all the things that happened, and we might have broken a few other things along the way, which we didn't even know about up to this time, right now. And this is not a very fun place to be. And one of the reasons it's easy to break legacy code is because it was written by someone else, by that guy, which we tend to hate that guy. We don't like that guy. And he wrote the code as best as he knew, but at the time he wasn't aware of all the features and complexity. And he's not around anymore, and we are stuck with this mess. The reason he's not around is that once a project ends, he moved on. He moved to another project in the company. He might have moved to a different company. Right now, I'm working with a team, outsourced team. We're fixing or writing a new feature, and there's no one, not a single person in the company who knows how the system works, because all of the teams that work on that specific product left, went to work for other companies. And we're trying to understand what the hell happens there. And that tends to happen quite a lot, because every 2 or 3 years, people tend to change jobs. But there is one thing about legacy code all of us need to remember. It has users. That is the sole purpose of this lecture. That is the only reason we are actually working with legacy code. Someone likes that code, wanted to continue on working, very passionate about that code as well. And we can't let them down, because they'll get angry. And we want them to continue on using the same features they've been using till now, give them new features perhaps. In some projects you need to continue development. We want to fix bugs. There's a funny thing that happens from time to time. You fix a bug and you notice that the users actually want the bug to happen because they found a workaround. That's the way they work. And it happens with legacy code more times than you expect it to be. And those users, we need to keep them happy. And so we are faced with a problem. Very hard, not fun to maintain code with people that actually want us to do that. And there's a simple solution to this combined from for the solution, the good news and bad news. The bad news, first of all, there's a lot of legacy code in C++. It's been around forever in computer science terms. Been around before I've started working, will be around probably for many years. A lot of C++ code out there in organizations that want that code to continue on working. On top of that, you are probably working with legacy code at the moment. Who here has started a new C++ project in the last year? Exactly, 0. Oh, 1. 2. First of all, lucky you. Second of all, your code, unfortunately, will become legacy code at some point. Maybe in a matter of months or years. Someone else will end up maintaining it. So most of us, if not all of us, work with legacy code right now. And we always need to read more code than we actually write. And lastly, C++ make it very easy to make very big mistakes. Memory allocation problems and buffer overflows, easily created if you don't really understand the system you're working on. And in C++, you don't even get a good error message. You get a code dump if you're lucky, or impossible to understand crash in most of cases, again, depending on the job that was done by someone else. The good news, though, is that C++ is a powerful language. C++ has many features which I can harness to work with the legacy code, which would make my life easier, which I wish I had in other languages. Those nice garbage collected languages like Java and C# won't enable me to do most of the tricks I'll show you today, because they are safe languages. And in C++, I can use those powers in order to work with legacy code, in order to change existing code without causing harm, some of the time without actually changing the production code, which I can't do in any other language. So, the simple algorithm for handling legacy code. First, learn what the code does. Seems trivial, right? I can't tell you how many times I've seen people, a developer faced with a problem, first of all, will write more code without understanding what the code does. I've actually worked with companies in which I needed to implement a new feature, but no one knew what the old system did at all. In one company, they gave me a very long method that did something very important, C++. And the first thing I did is debug that method, try to understand how that method behaves. Second thing I did, I broke it into smaller methods. And then I took a pen and paper and drew a bunch of rectangles, connected them with arrows to show how each method called each method and what happens in each and every one of them. It took me about 3 or 4 pages to write that specific method, one method flow. Then I went to the client, showed him that flow, and together we found out a bunch of calls that were not needed at all, never called, just left behind because people patched that code over and over and over again. And they were so happy, they wanted me to copy that page so they can hang it in the development room to understand what their code does. So first of all, you need to understand what the code does. Once you do understand what the code does, you need to make sure it keeps on doing that. This is the harder part. You need to make sure that no matter what you do, at least the features that the client wants continue to behave the same way, exactly the same way. And when you have those two, you can start on doing the fun stuff. You can refactor, change the implementation, optimize the code, maybe, cut a bunch of things out of it. And that is usually what people start with, but you don't want to start with the third point, because you'll probably break something. And you can make bigger and bigger changes and riskier changes as you go along, and you gain some understanding of what the code does. Now, those 3 are easier said than done. Otherwise, the session would have ended at this point. And they are quite trivial to think about it. And there are a bunch of tools that help me, both analyzing the code and working with the code, static analysis, debugger, logging. But there is one tool I found out to be very useful. I'm biased, I know. And that is unit tests, or specifically automated tests that I can write. And once I do write those tests, I can first understand what the code does, because in order to write a good test, I need to understand how the system behaves, how to initialize it. You know, new seems like a trivial thing to do in the class unless it calls a database, a server, and crashes 5 times along the way. Maybe it has dependencies, who knows. I know what the inputs I'm supposed to gain and what the expected result. And when I have enough of the test, I took care of the second point as well, because I have the safety net that will protect me when the code misbehaves, when I accidentally introduce a new bug. And then I can do the third one really fast. Once I have the test harness in place and I have the safety net in place, I can start really cutting things out and changing stuff and optimizing the system or whatever else you need to do. And all of those done with unit tests. But what is a unit test? Another term that no one ever defined properly. The way I think about it, it is a simple method. This is it. Who worked here with Google tests before? Okay, more than the average. Usually I get 3 people raise their hands. So no need to go over it too deeply. But every single what we tend to think of as X unit frameworks have the same structure. It doesn't matter if it's C++ or Java. I have some way to tell whoever is going to run the test that this is a test. In Google Tests, it's a macro called test, and a class behind it, which we tend to call test fixture, and the test name. This is a test. And then I have the body of the test, which is essentially just a method. I can write whatever I want. There are rules to write in it properly. Unfortunately, we won't be able to cover all of them. And at the bottom, usually I have an assert that checks whether or not I got the desired result. And when running that test, I can make sure that if someone accidentally changed the code in some way due to a new requirement change or a bug, then when running the test, I will get a failure. Whoever understands this reference is a lucky person. Whoever doesn't understand that specific reference, please go to YouTube, write Monty Python and the Holy Grail, and enjoy yourself. So I'll get a failure. Enough tests, I'll get failure whenever I break something, and then I can go faster because I have this safety net in place. But it's not the whole story. Unit tests are not enough because I have something nasty called dependencies, right? My code doesn't work on its own. Taking a single class, creating it on the stack or whatever, and running it is almost impossible in every single system I ever saw. We have dependencies. Those dependencies are a pain. They'll call the database or use some environment I don't have on my computer, or perhaps call someone else's code which I don't want to run right now. And those dependencies need to go away, at least for the purpose of testing something specific. And we use something we call fake object to do that. Anyone ever heard the term fake or mock? Okay, 1, 2, 3, 4, quarter of the room. The rest of you know how to write those fake objects, don't worry. The reason I call them fake objects, not mocks, because I think that the term mock is a bit misleading, also make you feel frightened because it's a new term. Basically, what I need to do is something you always did, inheritance. I use inheritance here in most of cases, because I'm not really calling a service or a file or the database. Well, this is a C++ room. Some of you might have written the actual layer that calls the database. But other than that, I'm calling a class, right? I have this class, which if I'll call some method on it, it will call the database or go outside using an HTTP call or save a file. And that class can be replaced with a class that looks exactly the same but does absolutely nothing. This is the fake object or the mock object. And we do that with inheritance. If I inherit the same class, override all its method, I'll end up with a class that does absolutely nothing. This is mocking framework 101, by the way. And in Google mock, I can do that by inheriting that class, just like here. Okay, this is inheritance, basic inheritance. Unfortunately, in C++, although I need to write that class, I don't like to write classes for testing purposes because I need to maintain them. But this is almost as good as it gets. If you want to see more options, come to my session. And in Google in Google Mock, I'll inherit a class in the test project, and then use those macros over here to override the methods. Those macros, mock underscore method and the number, basically, what they do is when they during compilation, they will override that method over here, and they'll replace it with absolutely nothing. Return, well, this is a void method with 2 strings, and this one will return a null pointer. Absolutely nothing. The reason I'm using Google Mock is to save myself some work. That work being, in every single test, I will want a different behavior. Maybe I want that method to throw an exception to show that the server wasn't available. Maybe I wanted this method over here to return a specific value. Or I just want to make sure that that value was called. Doesn't matter. And it looks something like this in code. Here I have a test written with Google Test, with Google Mock. If you've never seen that before, we'll go slowly, don't worry. Basically, I just want to check this method, calculate next data. That method does almost nothing. It's a distributed calculator. It goes to the database, get the next 2 numbers, it gets a tuple back, and then it creates an HTTP GET call with the client, calls the server in order to add those 2 numbers, and then return the number as integer. That code has many bugs, by the way. I know you can see some of them at least. You can get an exception, nice exception here as well. But it also has 2 dependencies. First of which is the data access. I don't really have a database in my test. And second of which is the client. I don't want to make sure that the server is out there expecting my call. And what I'll do is fake those. Here is the first fake REST HTTP client. I'll inherit the real client, and then mock the method HTTP GET. Now it does absolutely nothing, and that's it. If you want a good exercise in reading C++ code, go into this macro and see what happens. It's very tricky yet very interesting code to read, if that's what you enjoy. But for now, let's just assume it overrides the method, and that's it. And same for the data access. Here I have a const method, so I use mock const method with no arguments that will return a pair of 2 integers, and that's it. So now I have those 2 mocks. Another important thing to say is that those 2 mocks only exist within my tests. They do not belong in my production code. Okay? And going here, this is the test. I'll create a fake data access. Nothing much here. And then I'll use Google Mock to say I'm expecting a call from that fake data access with the method getData. And I want you to always return this specific object. Okay? So instead of doing nothing, now whenever I'll call that method, I'll get that specific value back, a pair of 1 and 2. And I'll do the same with the client. I'll expect you to call HTTP GET with that specific string at least once and return 3. The reason I'm using at least once, this is basically, well, there are different mocking framework in C++. In case of Google Mock and at least one other one. Here I tell it not only what to return, but the fact I actually expect that method to be called. The reason I want it to be called is because this method, the one I'm testing with the real object, does not return anything I can check. Or at least I don't care about whatever it returns. So the result of that specific test is that this method was called. Instead of checking for value, I'm checking for interaction. I'm checking that this method was called with a specific value, because once I go to the client and call it with the right arguments, I'm done in this specific test. Tricky, but mocking basics. So once I get this method called, I decided what comes back, right? So I don't really care about the result because I told him exactly what to do. And Google Mock works, so I don't need to test that one. And If you go and try to run that method, I'm using, by the way, that will work on Linux or whatever, wherever you run C++. Here I'm running on Windows using ReSharper for C++, excellent tool by JetBrains. And I'll go into that method, calculate next data, after I've set it up with everything I need. And we'll notice that data is returned exactly as I expected to be, 1 and 2, because I told them to. And the data access is a type of Google mock, gmock data, a bunch of things here, don't really care about them. And if I go over here, create some string, and I'll send that string with client HTTP GET, and running, I'll get a test passing. If I'll mess up this test and cause it to expect something completely different, let's say this, for example, and run it again, then I'll get a failure, which is a good thing, because if someone will change the actual query I'm sending back, then I need to know about that. And the good thing about using mocking framework is that they will also give me a good error message, because the only thing I care about unit tests is when they fail. That's the reason I wrote it. And it says, Google Mode tried the following one expectation, didn't match, blah, blah, blah. You expected to get this, but didn't happen, and so on. But you got this instead. And now I can fix the bug. So this was mocking in 5 minutes or less. Armed with those two, I can test legacy code. But it's not always that simple, because I used injection here. I passed all the object dependencies from outside inside my class, not always possible. Second of which, I've assumed that I can actually override those methods. Also not true for most systems I worked on. And there are different dependencies out there, not all created equal. Some of them are harder to mock. Some of them impossible to mock. For example, if I don't have virtual methods in my class, because this code was written many, many years ago without tests, and that doesn't have any virtual methods. Sometimes it's as easy as making that class virtual if you're allowed to, because there are performance implications. But if not, you have a problem. You can't use inheritance. Second, some classes cannot or be inherit, or very hard to inherit as well. Well, in C++11 we have final, which means the class cannot be inherited at all. And someone might have used that. And there are static methods. Again, you can't fake static methods because you can't. And singletons, a lot of code I see has singleton pattern implemented some form or the other. And some of which call the singleton many, many times inside the code, not pass it from outside using dependency injection. That is a problem. Some classes are instantiated inside your code. You have new in the constructor. You can't push it from outside. The easy solution in this case, create another constructor for your test and push it from outside, but it's not always possible. And heavy classes, classes that do a lot of things. My class does the calculation, calls the database, calls the service, everything includes together in a huge, huge class. And I can't break it. Not right now, because I will break my code without noticing. And I need a way. Let's start with singletons. This is a poorly implemented singleton I wrote. And in singleton pattern, wherever you look at it, it has an instance that will get initialized in some way or another. And when someone calls that class, it will call .getInstance or whatever you called your method, and try to do things on top of it. And it's not always easy to fake, although it's easy to use dependency injection. So here I have this is the trip service kata, which I converted to C++. The code is on GitHub. I'll give you the link. And here I have a single method, get trips by user. Get trips by user will have a user pass to it, someone I want to see his trips. And then it will use the user session, which is a singleton, to get logged user, essentially me. And if it doesn't get it, which means you get null pointer back, I will get an exception. Now, I can test for that. Actually, behavior I want to test for, but it's not that interesting. So I wanted to return an actual user, but I can't. because there's no session. There's another problem in this test, we'll get to that later. This is a static method call, which I also have a problem to fake. But let's start with a singleton. Here we have user session, it has get user instance, it called a method. That method, in order to show you that I have nothing up my sleeve, will throw an exception to signify the fact that there's no session. I hope the code doesn't look like that. But for our purposes, that's good enough. And the singleton, poorly implemented singleton, because you can probably think of at least two problems here if you think about it. We'll check whether or not the instance is null, and if it's null, it will instantiate a new instance. Now, I want to get to that instance here, and I can't, because it's a singleton. That's the whole purpose of writing a singleton. I want to replace it with my own fake object, which I can't again, because it probably has a private constructor as well, and that's a problem. So what I'll do is use the friend keyword. Ever heard about the friend keyword? Enable me to touch this class private parts from outside, from specified class. And I use it in order to enable two classes to change things inside this class. Fake user session that I will use in order to mimic the user session behavior, and something I called user session accessor because I'm bad with naming stuff. And those two do not belong in my production code, but I do need this code to compile. So I'll use for declaration just in order for the code to compile, but they don't exist in my production code, because if I'll write them in my production code, someone will accidentally use them in my production code. I have very funny bugs to handle. So I'll create those two, and those two are implemented here. Here is a fake user session. It has two methods. This user logged in and get the logged user. This method will get a user back and return a Boolean value, and this one will return a pointer to my user. I know that better ways to do that. And I have the user accessor, and the user accessor, all it does, it has a set method that will receive a user session, which hopefully will be a fake one. I did those two lines just to make sure I'm deleting the instance. I didn't want to check whether or not there's an instance and then delete it, so I'll cause it to create a new instance, then immediately delete it, and set that instance with my own instance, which means I can write this code. See? I have a fake user session, and I expected when someone called get logged user to return a user. Don't care which. And then I'll use the accessor to change the singleton. Now, the good thing about singleton is that inherently I can touch it wherever I want in my production code, and from now on in my test as well, so I don't need dependency injection. It is the dependency injection. And I'll create a real trip service, add a new friend, call it with two trips, get the trips back, and check them. This test, unfortunately, doesn't pass yet because I have the static method. But this test here, that just want to check whether or not a user will return no trips at all because I don't have any friends, which is a shame, but this is how it goes, will pass because of what I did. Okay? If you have any question at this point, feel free to raise your hand. I'll answer them. If not, I'll continue. So we can easily change singletons by hacking them using friend. But not all methods are fakeable, right? Not all methods are virtual. There are static methods out there, and there are final classes which I can inherit, and so on and so on. And now I have a problem. If I can't inherit the class, it means I can't fake it, right? Right? Well, you know it's a trick question because the answer is no. I can actually fake it. And the reason I can fake it is because I can use something, another trick from C++, using templated methods. Essentially, templates are immensely powerful construct, which you should use with care. And using templates, I can create a form of compile time dynamic sort of thing that's known as duck typing, and replace one class with another class, my class, that look exactly the same, doesn't need to inherit from that class, which means I can create any class. It will work for static methods as well, which is a nice trick. I wish I had it in C#. And I can fake unfakeable classes as well. And I can also fake classes that are created inside my method as well. But I need to change my method and my class, not always for the better, but it depends on what I'm trying to achieve. And here, I told you that I have a problem in my trip service. I have a static method called here that supposedly calls the database, but you might know by now that it throws an exception in this specific piece of code. And I need to replace that. And I can easily replace that by changing my whole service a bit. I can change it to this. You see what I did there? I've added a small character here, a T, and that's it. Well, it's not that's it. Anyone who ever worked with templates in C# and C++ know that it's not as simple as that. I also needed to change my class to be a templated class as well. And this T is being used here instead of my actual data access layer. Here, I'll go back one step. You see how this became something a bit different. Now I can replace this call with any class that has a static method that look the same way. I have one user in, return a list back, a vector, and that's it. And going back to my test, it has changed a bit as well. The old tests still use the data access because they don't care. And usually what I would have done in this point is not change my original class. I will create a base class with the T because I don't want anyone using production code to bother himself with passing this argument along all the way. But at least at my test, I can use a fake trip service now. And that fake trip service doesn't use any mocking framework. It's a static method, but it will always return user.trips or whatever I tell him to. This code essentially resides in my test and does whatever I need in order for my test to pass. Because all I care about is if the database returns this specific list, then everything else works according to what I expected it to do. So going back to my test I didn't pass before, I can add 2 trips to my friend. I've already created a fake user session and set it up so that it will return my user I've created, who also has a friend now. You see, he's my friend now. And when I call get trips by user, let's see that in debugging, then everything should work. This being a session demo, I always say should, because you can't know what I missed. But here we go. Going inside here, I'll get a user session and magically got a logged user by using the powers of mock object. Because looking at this method, it should have thrown an exception, but I've faked it out. And if we go in a bit, it's a logged user, and I'll get my friend, and it is in fact my friend. So I want his trip list. And going inside here, you see I've jumped into the fake object or hand-mocked object. I've just created it and returned exactly what I told him to return for the purpose of my test. And that's it. And now the test returned exactly what I expected to do. And having done those 2 things, written 2 more tests, I can now really change this code. I can go, because this code should be split into different classes, and now I can do whatever I want, because I know I have 4 tests that protect me. And usually it doesn't become 100 tests. For every piece of code, you probably have a few tests that will protect whatever you are trying to do right now. There's another thing I want to fake from time to time, or at least test, depending on the purpose, and that's a private method. Now, I get this question quite a lot. Some developer will come to me and ask, how do I test private method, or how do I mock private methods? And usually my answer is another question, why? Because when you think about it, you shouldn't do that. You shouldn't test private method. You should test your API, your contract, which is usually a public method. But unfortunately, with big legacy classes, you have a lot of dependency, a lot of things happening inside, and you might need to fake the private method or the protected method, which you can do or need to do because you can't fake the public method for some reason or another. Another cool feature in C++ is that when using inheritance, I can change the accessibility as well. I can make a private method a public method. Did you know about this feature? This is a very cool feature. Can cause a lot of grief and harm, but in our case, it means we can fake or call any method we want to. Just inherit your class, and there you go. If it's virtual, you can fake it as well. If not, you can call the method. And that's about all the time I have, because there are many other tricks to handle legacy code. Most of them written in the book, handling legacy code, honestly, by Michael Feathers, which you might want to read. And most of them you already know. You can, for example, one client came up with the idea that during compile time, they had this, usually when you need, at least in all C++, to work in a multi-platform environment, you have a problem when you need to read the file or create a new thread, till C++ 11 at least. So everybody has their own implementation for Linux and Mac and Windows or whatever. If you've been in that project, you know what I mean, right? Anyone here ever written a specific platform code? If they use if-defs or use compilation or whatever. So that client thought of the bright idea, and it is a bright idea, I'm not cynical here, of using the same device, the same method they had, to replace those implementation with fake objects. Instead of creating a file, just write outside someplace I can read later, I've just created a new file. Raise a flag or something. And during compilation, for those tests, it replaced all the implementation to a fake implementation for those specific methods. This is another thing you can do. And there are many other tricks you can do. Usually, I can get away with creating another constructor and replace the functionality, because in C++, when I create a new constructor, I don't need to call the base class constructor like any other languages such as Java or C#. So I can fake away bad things that happen in the constructor that I don't want inside my tests. And I can push dependencies in instead of the dependencies that were initialized in the constructor. This is actually a good design decision to do. And some of you might think, and you rightly so, that I've just messed up the code in order to test it, right? I've just took readable code and open up a bunch of holes inside of it, replace it with fake object, created templates, right? And it's not always that clean. But you have to remember something. This is a process. It's like renovating your house. Or last year when City Hall decided to replace a roundabout I had in the end of my street with a big junction with 3 lanes in each direction. In the beginning, it's very painful. I had a problem to get to work. But once they've done, everything is beautiful and working. Because legacy code, getting handle on legacy code, fixing legacy code is a process. And after a few days, weeks, maybe months, you'll end up with a better design. Probably flexible design, easily maintained. Not on your first test. And you have to remember that. So how do you take control of existing legacy code? I'll start with the legacy code. Usually you need something before that, something to calm you down, a cup of coffee. And then I'll understand what the code does and start writing tests. Once I write tests, I use fake objects to break away the dependencies. I'll end up with loosely coupled code, which I can test and improve. And I can swap the dependencies out, bring in new stuff. Usually my feature will get sorted on the way as well. The new feature, the bug fix, and I can refactor and clean up. And after a few iterations of this specific flow, I'll end up with more maintainable code. And you know what? The next person in line will appreciate it. It might be you. So you want to do that. It looks like a lot of work in the beginning, but it's usually less work than fixing something, then fixing the mess you made, then fixing the first thing again, and so on and so on. This is essentially what I do. When I come to organization, usually they only call me when things really messed up. You start by breaking things up. Thank you very much. That's all the time I have, unfortunately. If you have any question, please come to me afterwards. I'll be happy to answer them. And I have another session tomorrow on mocking frameworks and unit tests in C++. Thank you.